Broadcasting live from our studio in Boston, Solutions Review is proud to showcase Upsolver in the Solution Spotlight, a unique online event for industry professionals.
I'm Doug Atkinson here at Solutions Review, and welcome to the Solution Spotlight featuring Upsolver, and focused on how to move data into analytics platforms at scale. There is a simple truth that all organizations must recognize. Data is not information. So there is a need for you to find the right solutions that unlock the wealth of information encapsulated in the data continuously generated by the production environment of every modern business. Today, we're going to show you one of those solutions, the no-code and low-code authoring experiences offered in Upsolver, a cloud-native data ingestion solution designed to make it easy for data developers to deliver high-volume, complex application data to analytics users. And joining us to walk you through the Upsolver solution is Jason Hall, Senior Solutions Architect. Jason, thanks for being with us.
No problem. Excited to spend the time.
I think we're theoretically next door neighbors. I know you're in Massachusetts as well. So it's always nice to talk to someone who's a native of the area. But before we get into the actual event, tell us a little bit more about yourself, other than where you live. A bit about your journey and kind of how you found yourself at Upsolver.
Yeah, awesome. No, it's always good talking to a local. I certainly recognize all the bridge imagery in the intro. My name is Jason Hall, Solutions Architect at Upsolver. I've been in the data space for the majority of my career, going back several decades, starting managing large-scale, expensive on-premises database servers, as were the norm 20 years ago, and continue to make up a good part of the landscape today. But over that journey, I've kind of followed the evolution of the data landscape, kind of moving towards less expensive open source data platforms, moving into cloud hosted platforms, and kind of where we sit today in terms of analytics and really cloud native platforms. So spent the majority of my career in data in a variety of different roles, most of which were customer facing. So looking forward to spending the time showcasing Upsolver today and kind of showcasing what types of data problems we can help customers solve.
Yeah, great. And I want to let you get to that. Before I do, I just want to set everybody's expectations around how we'll flow today. If you have any questions, we would ask that you submit them into whatever system you're using, and we'll ingest them here. And ultimately, we'll end up, after Jason's all done, with a little Q&A. We'll take whatever questions we get. I'll have some questions as well, and we'll go through those together. Otherwise, Jason, I'm going to turn it over to you. I'm going to give you the floor, and feel free to walk through all the bits and pieces. We're certainly looking forward to a demo as well, and then we'll jump back in when you're all wrapping up.
All right, sounds good. So thanks for the handoff, Doug. So bit of the lay of the land, how we're going to spend the next 30 to 40 minutes. I'll kind of set the stage in some slides talking about Upsolver and talking about the kind of the landscape and ecosystem that we fit in, and specifically the types of problems that we're tasked with helping our customers solve. We'll also spend most of our time today in a live demo, so I'll give you a good feel for the user experience in Upsolver and showcasing some of those capabilities. And then to Doug's point, we will definitely look forward to any and all questions that you do have. So feel free to submit those. Always like hearing from the audience, and always enjoy answering any questions that you might have over the course of today's presentation. So I've already introduced myself. I'll give you a little intro to Upsolver as a company. Upsolver is a company that is tasked with helping customers ingest high-scale workloads into their analytics platforms. It's really a company that was born many years ago to solve this very specific problem. Customers looking at very large, very high-scale data sets and needing to provide analytics on top of them. And that's really proven by our customers. If you look in the lower right-hand corner of the slide here, the majority of our customers processing, what I would consider to be very large-scale data volumes, Over 50% of our customers processing more than 10 terabytes a month of data through Upsolver, and approaching 10% of our customer base working with more than a petabyte of data a month. So this concept of high scale is something that we're going to be spending a lot of time on during today's session. And that's really my objective, is to showcase how Upsolver can help customers work with high scale data, specifically on ingesting that data simply into their data lake or data warehouse environments. If we take a step back and kind of look at the modern data stack architecture, the modern data stack was kind of formed several years ago, really kind of born out of the increased adoption in cloud native technologies for analytics. And the modern data stack really implies that we really need a mechanism for ingesting data into our data lake or warehouse so that we can provide analytics value on top of that. And it was really a movement to simplify that data ingestion process, right? The theory that these legacy ETL platforms of prior decades were just too complex and too cumbersome and too limiting to ingest the types of data that we need to work with inside of the modern data stack. Right? So if I'm going to kind of overly simplify the architecture, it's often compartmentalized into data sources, data ingestion processes, data storage, and then finally data transformation. Now there's a large ecosystem beyond these four components, but for today's conversation, I think this makes sense. If we look at data sources over on the left, I often simplify the data source into one of two categories. We've got kind of business data, and we've abbreviated this small data, the data that's really complex in its variety, not in its scale, right? So lots of third-party API endpoints, maybe SaaS applications, your ERPs, your web platforms that you might need to read data from, maybe small-scale database ingestions. But these business or small data sources, they're difficult to work with, not because each individual one is challenging, but because companies have lots of them, right? Dozens, hundreds, maybe even thousands of data sources that they need to ingest through their architecture. The second type of data that customers need to interface with is that larger scale data, right? It's often kind of abbreviated big data. Big data has a lot of different definitions, but think of this as like transactional interaction, maybe real-time data. This data is often generated by maybe event collectors, maybe logs written to an object store, maybe a real-time event message broker, Kafka or Kinesis, for example. Also, some of the larger scale database-driven ingestions would kind of fit into this category. Right? And these data sources are more difficult to work with because of their scale, right? Customers often maybe don't have lots of them, but the ones that they have are large in scale, large in complexity, and need to be ingested through their data architectures. Right? So those are the kind of the two different data sources that we often see, kind of segmented into two categories. And what we're going to be talking about today primarily are that big data, the large scale sources. Now, eventually that data is going to be ingested into a storage platform, either a data warehouse or data lakehouse architecture, and then you'll perform transformation and modeling on top of that. Now, if we look at ingestion specifically, there's really two types of ingestion that a company can perform, each kind of suited for the different types of data sources that we introduced on the prior slide. Traditionally, self-service data ingestion has been focused on that business data that we discussed, right? The data that's difficult to work with due to its variety and sheer number of sources, not in its scale, right? There's lots of SaaS ingestion platforms out there that were built to handle that particular use case. There's third-party connectors, there's custom code that can access various API endpoints. But really, those small scale data sources can be served via a variety of products or processes that are designed for ingesting that type of data. The large scale data that needs to be ingested traditionally has been handled through, we kind of refer to this as a do-it-yourself architecture, right? Developers or data engineers building ingestion processes to handle these large scale data sources. And traditionally, you can build or build these data ingestion processes through maybe data warehouse add-ons like Snowpipe or some of the AWS services, or you can leverage a variety of open source platforms, Spark and Flink being two very common ones, that you can develop on top of to build out your ingestion processes. Now, both of these types comes with a set of challenges. This traditional self-serve ingestion platforms typically aren't built or priced for high scale, right? Again, they're not designed to handle multiple terabytes of data ingested per day or per month, right? The do-it-yourself options typically struggle in terms of complexity, right? And data engineering resources needed to build out and develop and then eventually operate those do-it-yourself data ingestions. So you were kind of stuck in between here, right? The very simple self-serve platforms not designed for scale, the do-it-yourself options not designed for simplicity. Right? And so that's where a product like Upsolver can come in and help out. If we kind of expand upon the data ingestion architecture, you'll see from source on the left, a target on the right. And again, these large scale sources often fitting into three primary categories, right? Data coming from streaming platforms, data coming from large scale relational databases, or data coming from files, maybe semi-structured files sitting on cloud hosted object stores. And again, if we think of the do-it-yourself approach to ingesting that high-scale data, you can see reference within that gray box to a variety of the services that may be required to handle that type of data ingestion, right? These handcrafted solutions that have to be developed and operated by data engineers to handle the types of data ingestion needed into their lakes or warehouses. And it might involve platforms like Debezium for open source CDC, or Kafka Connect, or Flink for stream processing, or Spark for batch processing, right? Each of these open source services, again, can be developed on top of to handle the types of large scale data ingestions needed. And the sections on the bottom of the slide too, I would more refer to those as associated services to support data ingestion, right? Ingestion is one thing, but we then need monitoring to make sure that our ingestion processes are working properly. We might need data observability to make sure that we're ingesting good quality data into our lake or warehouse. We might need CI/CD orchestration in order to deploy and upgrade and update our pipelines once they're put in place. So bottom line is we end up with this do-it-yourself architecture ends up being a fairly complicated approach to large-scale data ingestion because of all of the services that need to be worked with, because of all the development that needs to happen, and because of all of the pieces that need to be monitored and operated once it's put into production. And what a lot of our customers tell us is that once they need, or once they get into the world where they need to start working with these high scale, very complex data sources, data engineering becomes a very scarce resource. Right? They just simply don't have enough data engineers to support the types of data ingestions and analytics projects that they need. We've worked with customers that were staring at weeks, months, sometimes quarters in terms of a development cycle to deploy a data ingestion process from, let's say, for example, a Kafka topic. We also struggle oftentimes, again, with fixing bugs or fixing issues in data quality. And all of this complexity, again, is really counter to why the modern data stack architecture was put in place to begin with, right? The modern data stack embraces simplicity, right? It's all about simple ways to get data into your data architectures. And do-it-yourself based data ingestion for large-scale data sources is really counter to that, right? So really what the Upsolver workflow is designed to do is to simplify a lot of this, all right? And I have one example here that I like to mention. We're going to showcase this in the demo, but one example of simplicity and really a strength of the Upsolver platform is how we can handle the evolution of your source data, right? Source data often comes from a variety of sources, might come from databases, might be, for example, JSON or Parquet files sitting on S3. And this type of data by its nature evolves, right? Data types change, column names change. The volume of data changes over time. And all of these evolutions of that source data introduce risk in, at worst, maybe harming the throughput of your ingestion, but maybe even worse than that, causing issues, with the output of data overall. And many of these things, Upsolver just automates the ingestion of, right? So data engineers can spend a lot less of their time fixing bugs or fixing quality problems and much more of their time developing new ingestion processes that are driving more analytics projects for their organization. And so if I go back to this architecture slide here, this general architecture slide, what you see in the middle of the screen there, a combination of open source services that are necessary to piece together to build out do-it-yourself data ingestion and the associated services that need to be developed, this is what Upsolver provides. Right? So I'm hoping this kind of paints a picture. Those of you that are working with Kafka Connect or Debezium or Spark or Snowpipe, those are the types of services that Upsolver's goal is really to make much easier in terms of building out an ingestion process throughout your analytics stack. Right. So with that said, we're going to jump into a demo here in a few seconds. I did want to highlight the fact that I'm going to be demoing the Upsolver user interface. This is really just one development experience that Upsolver does provide. I like to say that we kind of run the gamut from a no-code experience all the way through a code-based experience for those that might need it. We're going to be focusing on simplicity here during today's demo. So we're going to trend more towards the no-code user experience that Upsolver provides. But for those of you that do prefer code-based experiences or wonder some of the different interfaces that Upsolver may provide, I did want to highlight that those are options. I'll show some of them as we go through the demo today, but if you like to build your ingestion processes through CLI or Python SDKs or dbt models, there's lots of flexibility in terms of how you interact with Upsolver as an ingestion process. So with that said, we're going to go ahead and jump into a demo. We're now in the browser-based interface to Upsolver. Again, this is where we're going to spend the demo today, building out and operating and inspecting data ingestion pipelines, working against these large-scale data sources. And the majority of our interaction with Upsolver is around the process of building and managing jobs. Right? Jobs are these ingestion processes that can read data from a source and write that data into a target system. And I'm going to start by demoing for you what I would consider the simplest way for ingesting high-scale data. Right? We're going to go through a wizard-driven experience here, a quote-unquote no-code experience. We start by selecting our source and target. You can see a variety of sources that we have available. I'm going to choose Kafka today. Kafka as a real-time event stream that we're going to need to read data from, and we're going to write that data into Snowflake, right, as a data warehouse platform. But a variety of options, and you can see for yourselves what some of the sources and targets we provide are. Now, once we've selected our sources and targets, the next step is to create our necessary connection to our source. Now, in this demo, I already have a Kafka connection created, so I'll go ahead and use that. If I needed to create a new Kafka connection, though, we just fill out a simple form here, our host, our connection properties, give it a name, and then we will test and verify the connection as a part of the wizard-driven process. Right? But in my case, I'll choose a connection that already exists. And I'll pick a topic that I want to ingest data from. And I'm going to choose this orders LQ topic. This is what I'm going to be reading events off of. Now, if I scroll down here, you'll see that Upsolver can automatically determine the type of content that exists on that topic. In our case, we have JSON events that are loaded into Kafka. But just so you can see some of the additional format types that we can natively ingest, you can see a variety of options: CSV, TSV, Parquet, Avro. We can use schema registries if needed. So lots of flexibility when it comes to the type of content that Upsolver is going to be processing for you. But I'll choose the simplest option of automatic. And you can see now Upsolver does a sampling of events to ensure that we can find data and that we can successfully parse it. Right? We don't have to run a pipeline just to see if it's going to be successful in ingesting and processing. In our case, we've successfully parsed a sample of 100 events, and you can even browse through what those events are, just so you have the chance to make sure these events are what we think they're supposed to be and that the data looks as it should. So we've now set up our connection to our source. The next step here is to set up a connection to our target. Right? And again, our target in this example is Snowflake. Much like with Kafka, I already have a connection created, so I'll just go ahead and reuse that. But if I needed to create a separate connection, again, fill out a simple form, connection string, username, password, and we'd have a connection created to our Snowflake warehouse. And now we're just going to go ahead and set up a target schema that I want to create a Snowflake table inside of. I'll choose my JHall schema, and I'll give my table a name. I'll call this Kafka, so I know where it's coming from. And I'll call this orders LQ. Now, the last step of the wizard here is to configure the ingestion itself. Right? Now, I'm actually going to take all of the defaults on this screen because I'm focused in this first demo of just showing you the simplest way that we can ingest data from Kafka and load it into Snowflake. We'll spend a little bit more time on this screen here during the next use case. But again, really focused on simplicity. We're going to take all of the defaults on this screen and click next. Okay. Now, what this wizard actually did for us was create just a few lines of job code. And so for those of you that would prefer a code-driven user experience, I would classify this as a low-code experience. You can see with a few configuration parameters here defined through a very familiar SQL-like code experience, we can go off and run this command to build out our ingestion job. Right? And we can run this through Upsolver itself, or as I mentioned on the prior slide, we can run this command through a CLI call, through one of our SDKs. We can even build a dbt model that handles this exact ingestion processes driven through this code. But if you're not overly concerned about the code, you can click the run button. The job would go off and build, and within a minute or two, we'd have real-time data ingested from Kafka over into our Snowflake data warehouse. Now, so I don't have to wait the minute here for data to start being ingested, I did have a job that I've created ahead of time, so we have the chance to take a look at it. And it's this job called ingest Kafka orders LQ. And so once a job is running in Upsolver, this sounds obvious, it runs, right? It runs and it runs continuously, right? This is not a batch-driven process that we had to schedule to run once an hour, once a day. This is a real-time process that ingests data from Kafka in near real time, processes that through the ingestion pipeline, and updates Snowflake in near real time. Right? So we can see the status of this job is running. Now, we also, while this job runs, we provide observability into the health of the ingestion pipeline. Right? So this monitoring UI that we're looking at right now provides a variety of key performance indicators that can help us understand data processing. We have a summarized table here, which just shows us the metrics we think are most important, but there's an all list here if you want to look at all sorts of helpful metric data for inspecting the quality of our ingestion. And then we also have a variety of event graphs and metric graphs that will help you understand throughput over time. Right? So you can track the delay of your source and target data ingestion, how many events are being handled, what the utilization of your clusters are, and you can diagnose and debug any errors that might have returned as a part of your ingestion process. All right, so if you're an operator or an engineer that's tasked with managing production pipelines, you'll get a really nice user experience in Upsolver for tracking and troubleshooting the process of your ingestion pipeline. Now, on top of the observability that we provide into the pipeline itself and the ingestion processing, Upsolver also provides a lot of nice visibility into the quality of the data that's being ingested. right? And this is often a type of observability that is really handed off to the data warehouse itself, right? Oftentimes when customers start thinking about data quality, it's often not thought of in terms of the ingestion quality of data, right? It's after we've ingested the data, let's go check on it. But Upsolver provides you really nice observability into the quality of data as it's being ingested into your target, right? As a core component of your data ingestion. So we're now in a worksheet, and specifically in the worksheet, I want to call out over on the left-hand side of the screen to this connection catalog. And I'm going to navigate to my Snowflake connection here. And specifically, I'm going to find the table that we're ingesting data into. Right? So it was this Kafka orders LQ table within the JHall schema. And so if I open up this table, right, this is a table that we're ingesting into within Snowflake, but within Upsolver, we've got lots of useful information about the quality of that data that we're ingesting. At the table level, we can track information about event volumes over time. Right? We can also track lots of useful statistics about each field that we're ingesting from the source and into each column that we're ingesting into Snowflake. For example, you can see our field statistics here. We've automatically inferred all of the data types for each of those ingested fields. And we're showing you metric data, like, for example, the density of data within each record that we're loading into Snowflake. For example, 100% density means that each row in our Snowflake table has a non-null value within that field. Anything other than 100% could be just due to the nature of the data that we're ingesting, but it could also indicate a quality problem. Right? Some of you may have already noticed that if you look at the first column that we're ingesting into Snowflake that is not of 100% density, it's this phone NO column here at 0.21%. It's not hard to identify now just by looking at the next column here that it looks like we have some inconsistency in a column name within our source data. Right? This happens all the time. We've got a developer who changes the name of a column that we're writing data into in the source, right? Or maybe we've got 3 different applications loading similar data into a source, and they can't agree upon what to call columns, right? And here you can see an example of that. Some of our rows have a phone number in the phone NO column. Other rows have it in phone number, right? So we now have 2 different columns that basically include the same data. If we keep scrolling down, we can also see a discount rate column here. So we've got null values appearing in roughly 74% of our discount rate rows. If we keep clicking through these statistics, there may be some other things that might jump out at you. For example, we have 2 net total fields, right? And you could see of different data types. So here's an example of schema evolution at the data type level. The same column or the same field in our source events contains data of differing data types. Right? Now, in addition to the density metric, you can also see as you look to the right of this table of information about, for example, the top values within each column. Notice here the order type column has 2 different values of mixed case. Right? Some of them are uppercase, some of them are lowercase. May not seem like a big deal, but if we're grouping or doing aggregations on this column and there's case sensitivity in the target, this could actually result in some invalid aggregations. If we keep scrolling down, you'll see some data issues like another one that I do like to highlight. If we go to this properties field, it looks like we've got different attributes within the same property nested field, right? Each of very low density. So again, this is an example of a column name changing, right? This is actually a use case that we mocked up due to a customer conversation we have a few weeks ago where their source data had a field name that had a component of a timestamp in the name of the column, right? Or the name of the field. So every month they had a new field show up in their source data and they needed to figure out how to work with that in their ingestion. Now, if we keep scrolling to the right of this table, the other 2 columns I want to call out to you are these first seen and last seen timestamps, right? These timestamps tell you for every column that we're ingesting into Snowflake, when did we first see a non-null value within that column? And when have we last seen a non-null value? In the event that a field name does change, or there's schema evolution in a specific data type, or a new field was added to our source, or a old field was deleted from our source, these will tell you the exact timestamp when that occurred in your ingestion process. This can be really useful if we're simply debugging a problem and we want to know when did this value or when did this field first appear. It can also be very helpful if we need to correct or replay some of our data. We'll know the exact timestamp from when to replay the issue from. Right? So really helpful observability into the data that we're ingesting, in this case, into our Snowflake data warehouse. And that observability even continues down to the column level. Right? So for example, let's consider a use case where maybe over the last few hours, some of our reports, some of our business users that are running reports against this table in Snowflake have started to report some invalid aggregations occurring. Maybe there's a report that runs against states. In other words, they're looking at order quantities per geographic state within our source data set. And they've started to notice that there are some invalid states appearing in the source data. Right? You can, first of all, filter on a timeline within this data. Maybe the problem started at about 1 o'clock in the morning. So let's just zoom in on that particular time range. And then we can drill down even at the column level, for example, the customer address state field, and start to look for some of the problems that our end users are reporting. Now, the first thing you'll see here, you get a value distribution of states within that column. So far, it looks okay, right? 9% of our rows have a state of New York. But as I step through some of these most common values, notice some things start to appear in this distribution that don't appear to be legitimate states, right? Elizabeth and Front Royal, these aren't states from a US geography perspective. So we've got a problem now with some of our source data that's been ingested into Snowflake, right? We can see exactly when that started, and we can drill into the timeline to inspect that in roughly 0.18% of our data, we're seeing some of these invalid states appear. So really a strength of Upsolver is what we just demonstrated, specifically the observability into the ingestion pipeline, right? So we started with the simplicity of building the pipeline, but now that it's in place, how do we observe the quality not only of the pipeline processing, but also of the data that's being ingested? So the second use case I'd like to highlight in Upsolver is going to showcase how we can improve the quality of our data at ingestion time. Right? And I'm going to go through the exact same ingestion wizard. I'll go a little quicker through the first few screens here, since it's literally going to be exactly the same. I'm going to read data from Kafka, select the same topic, and I'm going to write data into the same Snowflake data warehouse, but I'll choose a different table here. And now we'll spend a little bit more time here on this ingestion configuration screen, right? In the last example, I took all of the defaults, right? Which was the simplest way to ingest data, but we've since noticed some problems with our source data that we might want to try and correct at ingestion time. So we can first give our ingestion job a name. We can also determine how many events or when should we start the ingestion process from, right? The default is to start from right now, right? So start from now and ingest everything, from now forward. But if you have historical data on your source, maybe historical files in S3 or historical events on the Kafka topic, you can also start from the beginning of your ingested data. This is how we might decide to reprocess or replay data that we've noticed a problem within. The next parameter here is how often we want to update our target. I mentioned Upsolver is a product really designed to handle high-scale data in near real time. But if you don't need near real time, you can specify the update interval here of your ingestion process. Maybe you're concerned about Snowflake cost and your business doesn't require near real time. So let's load data once per hour instead of once per minute. This event time column here, or this is a timestamp that Upsolver adds to each row in Snowflake that guarantees a strongly ordered timestamp for each event that we load into Snowflake. If your source data already has an event time that you can rely on, you certainly don't need to add this. But we find it's a really useful column to add to every row that we ingest into Snowflake so that you can guarantee the ordering of events and so that you can provide incremental transformations on that data, relying on this strongly ordered timestamp column to aggregate by. In step 2 here, you'll see an option to prevent duplicates. This is so that you can effectively ensure exactly once processing of event data, right? Maybe you're worried about duplicate events showing up in the Kafka topic or duplicate files showing up on S3. You can specify here a deduplication key. Think of this as like the primary key in your source data and what window you want to deduplicate over. So here we'll basically make sure that we're only loading a single order ID into Snowflake once per minute. If we get a duplicate event, that event will be discarded. And then lastly, down in step 3 of the ingestion, you can see our schema configuration interface, right? The default here is to ingest everything from our source exactly as it was in the source, including any evolution of that schema. But we can come in here and specify alternatives. For example, I may decide that I don't want a few columns loaded into my data warehouse. Maybe, for example, the source data here contains some PII that's unnecessary for the analytics that we want to perform. I can simply deselect certain columns and they won't be ingested into my Snowflake warehouse. We can also apply transformation logic to, for example, hash a particular column that we do want ingested, but not in plain text. Right, so using a simple hash button here, I can take the email address that we're ingesting, but apply a hashing algorithm to it. We can also set something called an expectation. For example, if you remember, some of my rows of data were null in certain columns. There was a discount rate field that was of a very low density. If I determine that that's maybe a concern, I might decide I want to set an expectation on that column where it's not null. And if I do see a null value, generate a warning, right? So that I can come back and inspect the amount of times that we loaded a null value into our Snowflake warehouse. If these null values are critical problems, we may decide to discard the record if there's actually a null expectation violation in ingestion. So as you've seen here, we can now go through this ingestion wizard to specify some configurations that should improve the quality of the data that we're ingesting. And if we step onto the next screen, you can see this has now added a few lines of configuration to our ingestion job. It's still very simple code, very much a low-code experience, or no code for that matter, but we've added configurations to exclude certain columns. We've added a dedupe configuration. We've added a transformation parameter to define an in-flight transformation to apply to this data as it's being loaded. And we've added an expectation to set that not null constraint on the data that we're ingesting. And this, again, we could go ahead and create this job. But if you want to look at a slightly more advanced example, and I say slightly, it's really just a few extra lines here. Take a look at the job code that we have here, right? Just a few extra lines that I've added, but you'll see in the column transformation section, we've been able to address, I was going to say most, but I think actually all of the data quality problems that we saw in our first use case, right? For example, we're taking the phone number column that we saw in 2 different column names and coalescing that data into a single column, right? So now our Snowflake table is not going to have 2 different columns with the same data. It's all be in the same column, right? We're also taking the net total here, right? And if you recall, we saw net total columns of different data types, right? Some were integers, some were double point precision. Here, we're actually converting everything to double and loading that into Snowflake. Right? If you remember that field name that was changing over time, this is a more advanced use case, but using some JSON functions, we can actually extract the changing field name and consolidate that into a single column within Snowflake. Right? We're also taking the order type column and converting everything to lowercase. Right? So really simple code here, but just by applying some simple transformation functions, we're able to improve the quality of the data that's being loaded into our data warehouse. Right? And to handle that issue that we showed you where invalid states were getting loaded into our data warehouse, we've also added one extra expectation here. Now, there's a variety of ways I could have handled this problem. I chose one of the simpler approaches. I just checked that the abbreviation of the state was 2 characters, as it should be for a valid state abbreviation. And if it's not, I want the record dropped from the data ingestion. Right? So this is now a variation of an ingestion job that can handle correcting and improving the quality of this data in flight as it gets loaded into the warehouse. Right? This is an approach that would often have required, without something like Upsolver, running transformations on the data after it arrived in the warehouse, which adds complexity, adds expense, and just adds a lot of steps to your transformation processing. And if I go back into the schema UI that we were looking at earlier for this now higher quality table that I've been ingesting data into, you can see, sure enough, we've got a phone number field that's of 100% density since we're coalescing the 2 columns into one. You can see, by the way, if we look at our customer email addresses, they've all been hashed and are no longer available in plain text in my data warehouse. You can see if I look at the net total column, I've just got a single column of a consistent data type. My order type column, we only have 2 distinct values now, all of which are lowercase. And if I scroll down to the state field and look at the individual state metrics that we're loading into Snowflake, we no longer have those invalid states showing up in the distribution of data. So we've basically been able to address these quality problems at ingestion time by simply applying some simple transformations to the ingestion and setting up expectations to ensure that our data is meeting whatever expectation constraints that we might want to configure. And just to showcase, we've shown a lot of our observability during this demo in a UI, which can be very helpful for interactively diagnosing and debugging various issues. But much of this data is also available programmatically through a set of system API and function calls. Right here, you can see a set of system tables that Upsolver can query from to, in this case, for example, show the status of our expectations. Right, over the course of this ingestion, we've triggered 17,000 invalid states, which have been discarded from our data warehouse. Right, and there are similar system tables that you can programmatically access to track the status of your ingestion processes, track the configuration of your pipeline deployment. So those of you that might want to externalize your monitoring and observability, you can use some of our CLI or SDK calls to run these various commands against the system objects and APIs that Upsolver makes available. The last thing I wanted to highlight in the demo, we focused specifically on a use case around a source Kafka topic. But I did also want to specifically call out our support for ingesting large-scale CDC data, CDC standing for Change Data Capture, which is a common approach for ingesting data from databases. And these databases are very complex in the amount of data and the scale of data that often needs to be worked with. And we have a very similar ingestion process that can be configured, really just as simple as what we just showed you in Kafka, that can handle large-scale ingestions from a source database. For example, if I'm going to go through a wizard with a PostgreSQL source, it's really just a matter of setting up a few configurations, choosing the schema that you want to ingest data from, and then stepping through the pipeline, stepping through the wizard to load Postgres data into a database, a Snowflake target. And all of the schema evolution use cases that we highlighted against the Kafka topic apply here as well. Right? So if new tables were created on Postgres, you can automatically ingest those into your warehouse. If a new column was added to a table in Postgres, we can ingest that. If a data type of a column changed in the source system, that will no longer break your pipelines because Upsolver is automatically handling the schema evolution from that source and ingesting that high quality data into your warehouse. The last thing I wanted to highlight in this demo is, again, we've been using exclusively the Upsolver user interface to walk you through some of the capabilities that we've shown here. But I did want to highlight one of our additional user experiences, and that specifically is an integration with dbt. Many of you out there who are familiar with dbt know it to be a very popular data transformation tool. dbt is traditionally used to model data transformations using SQL on data that's already been ingested into your data lake or data warehouse. Right? So dbt traditionally is not something that's used for ingestion. It's used for transformation of already ingested data. But there are lots of customers who really like dbt and all of the capabilities that it provides. And so Upsolver has added an interface to dbt that allows us to build dbt models that create the data ingestion processes that we've just shown you. Right? So if you'd like to use dbt for more than just transformation and also want to use dbt for ingestion, that's a really nice option with Upsolver. And you can see some very simple models here where we create a connection in a dbt model. And then we can set up an ingestion job using dbt that reads data from, in this case, Kafka, loads the data into Snowflake, and can apply those same settings that we set up in the UI around data transformations, data deduplication, guaranteeing ordering of data, setting up expectations. All of those configurations can apply within your dbt model to build out your ingestion processes within the dbt ecosystem. So very popular capability within Upsolver that allows you to build and manage your pipelines externally to Upsolver, but in this case within dbt core. So that's what I wanted to show you in today's demo. I hope the use case was interesting and resonated with a variety of you that are out there. At this point, I think we can turn it back over to Doug and see if the audience has any questions for us.
Yeah, that was great, Jason. Appreciate the deep dive there. It opens up a whole lot of questions, and actually, as you go into the deep dive, you tend to sometimes forget kind of the beginning of the presentation, and I think you did a good job of kind of showing where the integrations can happen. But I'm curious. Everybody always has something, right? When they're calling to engage or when you're speaking to prospects. Remind everybody where this fits and where you're seeing traction with prospects. I mean, where again, there's a lot of things that already exist. There's a lot of things that may be homegrown or kind of very customized. How does this come into that existing data stack effectively?
Sure. Yeah, it's a good question. And this, it's a good point. It's when we talk about the modern data stack, there's, I kind of implied it in one of the slides that I showed earlier. There's lots of different technologies and processes and platforms that handle each component within the data stack to some level of capability. Where Upsolver typically fits into an organization and where our conversations with customers typically start is when the customer has the need to start processing this large scale data, right? So, oftentimes when customers start implementing some of these analytics projects, they start with what's easy. And I'm trivializing that comment easy there, but they start with either because that's all of the data that they have or because it's the easiest data to start with. They start with low scale data. They start with, let's go get a few objects from our CRM system and load that into a data warehouse, right? Or let's go get a few different metrics from this API endpoint that we can pull data from, right? To where, that's kind of how they're starting their analytics journey in loading data into their data warehouse. And now eventually the customer either has the need because the business has started to generate high scale data, or they've already solved the simple problems and now they need to get to the hard problems, right? And so, for example, they've already read in a bunch of data from their CRM or ERP system, but now they've got this event stream that is generating millions of events per second. And the process they've put in place for working with simple data just isn't scaling, right? It's either not scaling technically or it's not scaling cost-wise. And so they need an alternative for working with some of these higher scale data sets. And that's where kind of Upsolver comes in. And it's a good point you made, Doug, is that Upsolver is not the product that's going to handle ingesting every type of data that you have in your environment, right? There's lots of vendors that do a really good job at handling small scale data, right? Where Upsolver's real sweet spot is when customers have the need to work with large scale and highly complex data sources, and they're finding that their current tool set isn't appropriate for that type of data, or they're finding that the complexity to build it themselves is beyond what their staff is ready to build and support.
Yeah, and I think that's an excellent last point. Is really what we're talking about is an incredibly advanced solution that's been developed over many years and many iterations and many client experiences, and so you are talking about something that just can't be homegrown at this point. I mean, it's just way too beyond. And I think that's one of the challenges I'm sure that you see, is that there's a lot of really smart people at a lot of organizations who want to try to solve this problem with either the tools they have or literally build tools themselves. And so let's talk about how they can work through that. So with regard to engaging, I know you know on the site there's all kinds of certainly a lot of information, and there's also demos which go obviously probably deeper than this. But talk a little bit about that. When somebody reaches out, talk a little bit about how you walk them through that consideration cycle. And actually, before you even get to that, because I think that's an important one, what should they be thinking about before they even make the call? What should they be preparing with regard to potentially bottlenecks or the points of integration that are needed? I mean, how do you see a good first meeting going?
Yeah, so the first time we start working with a potential prospect, whether this is them working on their own, doing some research, or whether we've had the chance to chat over email or over the phone, is we're trying to kind of qualify that the customer has a challenge and has a data set that they're struggling with that's a good fit for Upsolver, right? As I mentioned earlier, there's some types of data, the low scale kind of business data that we talked about earlier in the presentation, that Upsolver either doesn't work for or just really isn't a good fit for. So we're trying to make sure that the customers we're working with are those that have the challenges that we're suited to help them with. So, we look for, again, customers that need to manage real-time event streams. We're looking for customers working with Kafka or Kinesis, struggling to analyze that data. Or we're looking for customers that have large-scale database platforms. For example, a MongoDB system with hundreds of collections that they need to ingest documents from, or a Postgres system with dozens of tables that they need to work with. So that's the first level of qualification we're looking for. Does this customer have a large scale data source that we are designed to help them with? Beyond that, it then becomes where are the challenges in working with that data? Is it data freshness in Snowflake? Is it the quality of data? Is it the simplicity of working with that data? But the majority of times our conversation starts with identifying data that the customer's struggling to work with, ideally large scale data. If we can identify that, then for the most part, the conversation is pretty seamless from there. Upsolver provides a few different deployment models for a platform, but the simplest is that we do have a cloud hosted system that customers can get started with very quickly. Just go to upsolver.com. There's a sign up page. you'll get access to our cloud-hosted platform where you can connect to your data and start processing it within a matter of minutes. Very simple, easy to get started workflow. We do host a lot of public workshops for customers that might want a more hands-on experience and guiding them through some use cases like I showed you today. So that's another good opportunity to engage with Upsolver. Again, you're welcome to try it on your own, but if you'd like more of a guided approach, you can join one of our workshops that walks you through some sample data and walks you through some exercises to build out the types of pipelines that we showed you during today's demo.
Yeah, and you're doing a good job of knocking out some of the questions that I had received. But I do have and by the way, the point that Jason made earlier about trying to find that that right instance, right application effectively to leverage the power of Upsolver. That's an easy conversation to have, and it's a conversation we would encourage you to have. If you think you need a solution like Upsolver and you know who you are, you should absolutely reach out because these are easy conversations to have, and we always encourage everybody who's curious to engage, because ultimately you'll get to talk to smart people like Jason and get all the questions answered that you may have coming out of an event like this. But I do have one question for you that we got through LinkedIn. Can you use custom functions to transform data during ingestion? For example, rather than dropping the invalid states, finding the correct state, and keeping the record.
Yeah, so we provide a kind of a SQL-like experience for building out your transformations. There's a variety of ways that you can transform data either in flight or in a staging location. Something we didn't talk about today. We were talking more about direct ingestion into a data lake or data warehouse. Upsolver does also provide an option to stage the data in a data lake first, maybe then transform it and then load it into a target warehouse. And you've got a wide library of functions that you can call to perform string manipulation or convert the structure of maybe JSON into something different, or flatten arrays, or parse via regexes, maybe do date time manipulation. There's literally hundreds of functions that you can call out of the box to transform data either in flight or in a staging location prior to it being loaded. We also have some flexibility to roll your own transformation processes and functions. So easy answer is yes. We showed you some of the simpler transformation options during today's demo, just some kind of single line expression calls, but there's a lot of flexibility and a lot of power to transform data in a variety of ways should you need it.
Another question we have, which is an interesting question actually, regarding what monitoring solutions does Upsolver provide and or integrate with?
Okay. Yeah, that's a good question, because I often show like monitoring within Upsolver, but of course, due to the nature of the question, there's an awareness that monitoring is a much larger ecosystem than just Upsolver. So, if you're a data engineer who works in Upsolver all day, then obviously the built-in monitoring is likely sufficient for you. But if you're looking at maybe integrating monitoring into more of an enterprise scale or broader monitoring platform, there's a handful of options. We can integrate directly into something like an AWS CloudWatch or a Datadog, very common approaches. Take some of our metrics data and load them into an external monitoring system. We also talked about the kind of programmatic interface to our monitoring. So we have a lot of customers that are using, like, for example, our Python SDK to write monitoring-driven commands against Upsolver system tables to maybe load some of the lower level event data or lower level metric data into like a Prometheus or a Grafana or something like that for larger scale enterprise monitoring. So the easy answer to that question, or I should say the simple answer to that question, is we can more than likely interface directly with a monitoring solution that you currently use. But also there's a lot of power should you want to kind of build some of your own monitoring using one of our SDKs or CLI options for exporting or exposing the useful data that Upsolver does provide.
Yeah, great. Another question, and I'll just ask it. How does Upsolver work within a CI/CD development environment?
Yeah, it's a good question. And that should be something that any of you that are curious about CI/CD, ask any solution that you look at, especially those that appear very simple like Upsolver provides. A lot of times when you start talking about no-code experiences or wizard-driven experiences, those are really simple to get started with. But once you start trying to automate and add those processes through like a CI/CD pipeline, they start to fall apart, right? Simple when you're building 1 or 2 pipelines, but how do we build hundreds? So that's where the ability of Upsolver to leverage that no-code experience for your initial authoring is really useful. But that's where the low-code experience that I highlighted a few times, where just a few lines of SQL or those DBT models that I highlighted can help you interface or integrate, I should say, Upsolver pipelines with whatever your CI/CD pipeline infrastructure might look like, right? So we have customers, for example, using DBT within their CI/CD processes, and then leveraging Upsolver within those DBT models, or maybe taking a Python script that creates an Upsolver pipeline, checking that into version control, and then once it's checked in, using something like GitHub Actions to build and manage the pipeline moving forward. So lots of flexibility with an Upsolver to integrate into whatever your CI/CD processes might look like, using that low code based experience to build out all of your ingestion processes.
Yeah, great. Well, we're wrapped up. This was a great demo, great conversation, and we love highlighting solutions like Upsolver, next level, really well developed, and can provide a lot of horsepower and a lot of solution. So we would encourage you to go to upsolver.com and check out everything that they have, and they have a lot on the site, and obviously reach out and engage when you have a moment. Jason, thanks very much for the time today. This was a great walkthrough, and best of luck for the rest of the year and into the coming year.
Awesome. Yeah, appreciate the opportunity, Doug.
You bet. Well, there you have it. Another solution in our spotlight. We want to thank Upsolver and Jason for that fine presentation, and we appreciate your participation as well. Until next time, I'm Doug Atkinson here at Solutions Review. Thanks for watching.